Hello friends, I'm Bob. In this video, I will show you the solution to the Maclaurin series of 1 over 1 plus x squared up to and including the x to the power 4 terms using the formula shown in the top right hand corner of this video. But before I do so, if you guys like the solution, let me press the thumbs up icon below this video. The top right hand corner's formula tells us that a function of x can be expressed as an infinite series in which we will need to evaluate the following. f0 is the function evaluating at x equals 0. The function of x differentiated once and evaluating x equals 0, so that will be f prime 0. And then we have f double prime 0, the function differentiated twice and evaluating x equals 0. F triple prime 0 is the function differentiated 3 times and evaluating x equals 0, and f 4 times prime 0. So once we have found all this answer, we can substitute using the formula shown in the top right hand corner to find the Maclaurin series of 1 over 1 plus x squared. First of all, the first step we are going to do is we are going to let my function of x be equals to 1 over 1 plus x squared. Next, we find y is my f prime x differentiating fx one time. We get the following. In the denominator, I will square. So this is applying the quotient rule of differentiation. And then I will bring the denominator up to the numerator. I get 1 plus x squared. Differentiating 1 is 0, subtracting away, keeping 1. And then differentiating 1 plus x squared is 2x. So this gives me basically just negative 2x over 1 plus x squared squared. Next up, we will find what is my f double prime x. I will apply the quotient rule of differentiation. I get the following. My denominator is 1 plus x squared to the power 4. And then my numerator is just 1 plus x squared squared. Differentiating negative 2x is negative 2. Subtracting away, keeping negative 2x, and differentiate 1 plus x squared squared. So that would be 2 times of 1 plus x squared. Differentiating 1 plus x squared is 2x. And from here we can actually factorize 1 plus x squared in the numerator out. So we get the following. 1 plus x squared, square bracket, 1 plus x squared times negative 2 minus, we will simplify this, and this. So that will be negative 2x times 2x is just plus 8x over 1 plus x squared to the power of 4. Then we can further simplify and we get the following. Negative 2 plus 6x squared over 1 plus x squared cubed. We now move on to find what is my f triple prime x. So this is differentiating f double prime x one more time, in which I will apply the same thing, the quotient rule of differentiation. I get the following. In the denominator, I get 1 plus x squared to the power of 6. Bring the 1 plus x squared cubed up. Differentiating negative 2 plus 6x squared is just 12x. Subtracting away, keeping the negative 2 plus 6x squared. Differentiating 1 plus x squared to the power of 3. We have 3 times of 1 plus x squared, 2x. Same thing from here, we will simplify by factorizing 1 plus x squared to the power of 2. And we get the following. In the numerator is 1 plus x squared squared. And square bracket, evaluating the remaining, we get just 24x minus 24x squared. In the denominator is 1 plus x squared to the power of 6. So if we were to simplify, basically it's just 24x minus 24x squared over 1 plus x squared to the power of 4. Next, to find what is my f 4 times prime x, we will apply the quotient rule of differentiation one more time. So in the denominator, we will have the following. 1 plus x squared to the power of 8, and then bringing up the 1 plus x squared to the power of 4 in the numerator. Differentiating 24x minus 24x squared, we get 24, subtracting away 48x. Subtracting away, keeping 24x minus 24x squared. And then differentiating 1 plus x squared to the power of 4, we get 4 times the 1 plus x squared to the power of 3, differentiating 1 plus x squared times 2x. We have found the fx, f prime x, f double prime x, f triple prime x, and f4 times prime x. Next up, we will need to find the following function by substituting x equals 0. So for the first function, f0, substituting x equals 0 into fx, we get basically just 1 over 1 is 1. So f0 is 1. How about f prime 0? Substituting x equals to 0 into f prime x. In the denominator, basically is just here 1. In the numerator, we have 0. So my f prime 0 is 0. How about f double prime 0? Substituting x equals to 0 into f double prime x. I get the following. In the numerator, this term itself is 0. Whereas for the first term is negative 2. My denominator is 1. So this is equals to negative 2. Hence my f double prime 0 is negative 2. F triple prime 0, substituting x equals to 0 into f triple prime x. I will get the following. In the numerator, basically it's just 0. So if my numerator is 0, hence my f triple prime 0 is 0. Last but not least, f 4 times prime x, substituting x equals to 0. We will get the following. To find my f 4 times prime 0, in the denominator is 1. How about in the numerator? The first term, if we were to look very closely down here, this is 24. And then in the denominator, basically here, because my x is 0. So my second term in the numerator is 0. And my f 4 times prime 0 is 24. I found what is my f0, f prime 0, f double prime 0, triple prime 0, and 4 times prime 0. I can apply the top right hand corner's formula to find the Maclaurin series of 1 over 1 plus x squared. So this is approximated to be my f0 is 1 plus x, f prime 0 is 0 over 1 factorial plus my x squared is just x squared, f double prime 0 is negative 2 over 2 factorial. X cubed f triple prime 0 is 0, and f 4 times prime 0 is 24. To further simplify the answer, the second and the fourth terms are 0. So the first term is 1, the second term is negative x squared, whereas for the third term is just x to the power 4. Because we know that 4 factorial is 4 times 3 times 2 times 1, so this is equals to 24. And then simplifying the last term, we get x to the power of 4. And this is the final answer of the Maclaurin series of 1 over 1 plus x squared up to x to the power 4 terms. If you guys like the solution, let me press the thumbs up icon and don't forget to subscribe for more Maclaurin series problems. I'm Bob, thank you guys for the support, and I will see you in the next video. Goodbye guys.